So let's take a look at this question over here. We're given an integral. It's got a numerator and a denominator. The denominator is pretty simple, but the numerator looks a little more complex. So how can we solve this? Well, you might be encouraged to, try to find some manipulation with the numerator here, maybe factor it and do something there. And if that doesn't work, you might even try some sort of substitution. But remember, this is actually a very simple thing to do, and you often see stuff coming up like this in integration, where you can just break it up. So we can rewrite this without changing anything as the integral of x cubed over x minus 2x over x plus 5 over x. And now obviously each of these individual terms is much easier to deal with than what we had in the beginning. And so with that in mind, we can obviously now just simplify these. So x cubed over x would just be x squared minus 2 plus 5 over x. And to do this, remember, and the law exists, you don't have to actually write it out, but it might help you to write it out like this as the sum of different integrals. So we have, I guess you could write it like this. There are all sorts of simplifications you could do. You don't have to show all this work, of course, when you're actually solving it, but essentially it just becomes this, and you're ultimately going to get x cubed over 3 plus some constant plus negative 2x, so that's just minus 2x, plus 5 times the natural log of the absolute value of x plus some constant. So there are different constants for each of them, but you can put them all together in the form of just one big constant, and just like that, you're done. And yeah, I mean, this might have been a very, very easy question for you. Maybe you solved it in your head immediately, which is definitely feasible. Or maybe you actually struggled with it and you didn't quite think of this. And remember, at the end of the day, they're both, it's completely fine either way. Oftentimes, you'll get integrals that are actually the other way around, where they're written as in a form similar to this, and then the job is for you to give them a common numerator and then maybe do some factorization or whatever. But just remember essentially that you can break up larger integrals into smaller integrals, into the sum of smaller integrals in this way. And that's often a useful trick. Over here, this is just a very simple example, so hopefully it was still helpful for you. Hopefully you still learned something or practice with it. But keep in mind that this idea is actually much more powerful than it seems over here, and you can use it for all sorts of questions. Anyway, that's it for this video. Hope you enjoyed. Stay tuned for the next one. Make sure to subscribe, and thanks so much for watching.